How old are the prokaryotes known as archaea, which are a distinct group from the more common eubacteria? Well, genetic analysis certainly suggests that the division between archaea and eubacteria dates to the early moments of life on Earth, given the differences between the two. The fact that archaea often thrive in extreme environments, which would have been more common, the predominant types of environments in an early Earth, also suggests that this is an ancient group. The chemistry of archaea is different from that of eubacteria. The biomolecules produced by each group can be identified in rocks, in petroleum, and in other sediments. And so, therefore, chemistry can identify not only their presence in petroleum dating back into the Jurassic period, but into sedimentary rocks which date back to 2.7 billion years ago. There is even the possibility of tracing them back further by studying methane gas in deposits formed in rocks of various ages. Today, all methanogens, microbes producing methane, are archaea, and methane produced by living things differs in its isotope ratio of carbon 13 to 14 compared to methane which forms naturally. There is evidence suggesting that methane produced by living things, and thus perhaps archaea, dates back to rocks 3.5 billion years in age. Not only is this significant in suggesting the age of this group of modern prokaryotes, but also the methane that they produced would have been extremely important in determining the global temperature of the planet. At this point in Earth's history, the sun was not as powerful and the Earth would have been colder. But perhaps to some degree, because of the methane produced by these methanogens, the climate would have warmed to the point, perhaps even critical, in maintaining liquid water on the planet. Methane is a very powerful greenhouse gas and absorbs far more heat than does carbon dioxide. And so archaea are an ancient group, and the methane produced by some archaea may have been vital in establishing the temperature of the planet in the early Earth.